difference in the predictions. But in other cases, they don't. So ultimately, it will be worked out.
Oh, you mean your prediction involving the exact amount of refraction to make up the globe slant, no matter how you calculate it, using the arc sine of the distance over the radius or using the distance times 2 pi over the radius? You mean that?
No, I don't mean that. It's not about. It's about using standard refraction, letting the chips fall where they will.
Yeah, so using those corrections, whereas we have the raw calculations and timings and corresponding angles to draw the relationship. It's not really much of a
Right, but the nice
That's
thing
more
about
like,
it.
well,
Sorry.
it seems like what you've done is just turn stellarium into a spreadsheet.
Yeah, well, as I say, I mean, I'm not concerned. In the end, the truth will out, and I'm perfectly satisfied to wait.
Well, the truth is the time corresponds to one specific angle based on our projection. Yours is regarding refraction of a refracted image itself. So
Right, that's right. We make different predictions, and so the question ultimately will be which one is right. Or it's possible, of course, that neither is right. So that's another possibility. But they make different predictions, so they can't both be right.
Right.
What about Occam's razor?
That's why only one timing was measured. So you said you had some problems with the Blodgett peak thing. You want to go over those now, or is it still like a super secret project?
No, it's not really a super secret. Although I do have a question. Oh, in fact, Mike's here, right? Let me put this one thing. Well, so first of all, Jesse and Ruhith, I think, have been more on top of that. I guess they're waiting for time-stamped pictures or something, because I agree with them. I saw the thing that they saw in a different form. To me, I didn't understand what I saw as the elevation of the stars for Blodgett. I didn't see them as being in line with either the flat Earth or the globe, so I was confused by that. But it turns out that thing that I was seeing is the same thing. It turns out to be, in my case, I calculated it was about a 28-second difference. But I think I didn't know to think of it that way at first. But it's the same thing they're talking about. If I can post this one thing, go ahead and talk for a minute if you want, but I'm going to post something in the chat.
No, just wait for you to post it.
So in today's document, John, there's Blodgett peak data that was taken from a video, and that video hasn't been uploaded anywhere. But as soon as somebody can give me a link where I can upload these videos, I'll be happy to upload them so that anybody can duplicate this for themselves. But and I think the data that I gave you before, that was using my original method with a different piece of video software that it didn't tell me the frame number, so I had to carefully stop it and figure out where it was. The method I'm using now, I just read the frame number right off and let the spreadsheet calculate what the time was, and then look it up and copy and paste the numbers straight out of Stellarium. So today's theodolite celestial theodolite measurements document is probably the most accurate so far.
I'm not finding the main chat. Why is did something happen?
You should be able to get to it. It's where.
Well, hold on. I might have to run out and
Are you on
come
your
back
phone?
in. I can't find it there where I usually see it. I'm going to leave for a second. I'll be right back.
All right. Oh, the new celestial theody measures. Let's check them out. Oh, this is that spreadsheet you put together that has all the stuff you did. Ooh, nice, man. Thank you. Thank you. I didn't realize that's what you were talking about earlier. Fantastic. Yes, Dave, what's up?
Yeah, somehow I'm still not seeing it. I'm seeing off topic, endless debates, theology, but I don't see main chat. Why is that?
Right above. Right
Right above main
off topic.
voice. That's where, I mean, it's up at the top of the main, right?
I
Usually.
pinged you in there. Do you see like a little
Oh,
number
there.
one?
Now I see it. I know it
Alright.
just showed up. Thank you. Okay, so I'm going to post this.
Yeah, sometimes if you collapse a category, you're like, "What happened? Everything's gone." It's just
Yeah, I'm kind of new to Discord, so it's probably my bad. Let me see.
yeah.
I had
I'm
that
sure we've
same
all done it.
problem.
So
The growing
this is the thing. So I
pains.
just posted. I'm curious as to what I'm curious, especially about what the Sokia N010C line means in this little. And first of all, just is this yours? I think it must be, but
Yeah, I'll bring it up for
is
you,
this
John.
from you, Mike? And if so, what does that Sokia N10C line represent?
So cute. Where did you post that,
Which
John?
document is that in?
Yeah, you didn't send it,
Sorry?
John. You didn't send anything, John.
Oh, did I not? Oh, yeah. Okay, sorry. There it is.
Oh, here we go. I'll bring it up for you. It's on the main screen if you want to join the stream thing. Copy, paste, and go. Here we go.
Okay, so this looks like a screenshot of my original document where I predicted what I would measure from my front yard. So the Sokia N010C was the angle that I was expecting to measure, which to within the one arc minute accuracy of the N010C, that's what I did measure. So these look like it might have been screenshot from. Oh no, actually it looks like a screenshot of one of my spreadsheets. I'm not sure where that came from because I don't remember sharing that with anybody, but I must have shared it with somebody and they captured the screenshot.
Yeah. So what were you angry about, John? Just the Sokia?
So the Sokia N010C, that's the theodolite I borrowed from my stepfather-in-law that I referenced in the theodolite measurements February 26th document.
Right. Oh
So-
yeah, this is the one that you went around and confirmed the daytime measurements with, right? To follow up.
Correct.
So
Yeah.
I think those are not actually. I mean, I'm thinking that Sokia, that line there that says Sokia, they aren't measurements. You said at the beginning that they were maybe predictions.
Right. Those were predictions. So that ended up being the predicted, my prediction line in the theodolite measurements February 26th document. And then when you add the delta above that to those measurements, that's when you come up with the flat Earth predicted angle.
So what do you
And then
mean when you add the delta? What's the delta?
it's two lines up. Delta equals 4.4944 times 10 to the negative 6 degree per meter.
Oh, okay. All right. Oh, I see. Okay, I get it. Right,
So
because
if you,
that delta is exactly 8 inches per square mile. I know that. Yeah.
it's
That
probably pretty
number
close.
that you put there is 8 inches per square mile.
It's probably pretty close. I don't think it's exact because that
It's not
varies with
exact.
theodolite.
Yes, sorry.
So
My bad.
basically, what people are doing are they're using theodolites far beyond their specified range and expecting them to be accurate, and they're not accurate. So that characterizes the inaccuracy.
Well, I don't think that's right because a theodolite, I mean, when you aim a theodolite, all it does is tell you what angle it's aiming at. It has no idea what the distance is, so it can't, so that can't be the case. The only thing it can possibly mean is a correction. Once you figure the distance, there is a, you can, if you were to calculate a height, then you would know, if you knew what the distance was, that would tell you what the globe drop is. That thing times the distance will give you the globe drop.
So what you're saying is incorrect. All precision measurement equipment has tolerances, and that's the error in the instrument that delta represents. No, no precision measurement equipment is infinitely precise or accurate. They all have built-in deviations.
Right. I get that. But that
That's
number, that 4.4944 10 to the minus 6 degrees per meter, is literally identical to, I can show you why that is equal to 8 inches per square mile. It is literally 8 inches per square mile. That's
don't
not an
say.
instrumental thing. That's a globe thing.
Right. That's the point of
That's the
my
point.
theodolite measurements paper, that people have been mistaking that instrument error for evidence that a globe Earth exists, and they don't want to deal with the fact they're using that instrument far beyond the range it was designed to be accurate.
Well,
Well, that's
I mean,
unfortunate.
the instrument, it's when you point the instrument at something, all the instrument tells you is what angle you're pointing it at. That's all it does. It doesn't know what you're looking at. It just tells you what angle you're pointing at.
I think you're still missing the point about instrument errors.
It's the scaling factor. The farther away you are, the more that error compounds.
That's true, but in this case, the fact that that number is literally 8 inches per square mile
Yeah, it's
makes
pretty
it clear that
wild,
it's not
right?
an instrument error. It's about the globe. And you can consider it. I'm not saying you don't have to think that it's just a way of somehow, fixing. I don't know exactly how you want to use it, but that number is not an instrument error. It's about the globe. It's not about the instrument.
Dr. Mike,
So
is that an instrument error?
that is an instrument error, and it
Okay.
just coincidentally comes awfully darn close to looking like a globe, as the all theodolites do, and all theodolites have a slightly different number there because they have lens grinding issues, they have internal mechanical issues, they have calibration issues. There's so much that can go wrong. That just characterizes what the error of that instrument is. And oh, by the way, what do you know? It just makes it look like it's a globe Earth.
Well, no, because an instrument error would be expressed in degrees, not degrees per meter, because the instrument doesn't give a shit about the meters. All it knows is the angle. The instrument might point, it might be a precision. In your case, the precision is plus or minus a minute. And so you could say it's a 60th of a degree, but that's it. It's not
So
a degree per meter.
I'll propose a little experiment to you. Get a professional surveyor to sight his measurement stick and then have him change the focus and have him tell you what happens.
Change the focus? What do you mean?
So you're trying to say the distance has no bearing on this,
Change
but
the zoom level.
as you zoom from a few meters away, infinitely far away, you'll see the measurement shift.
So when you change the focus, the reading of what you're pointing without changing the pointing, you just simply change the focus. The reading that what it's pointing to changes. That's what you're claiming.
Right. And some of that is intuitively obvious because you'll see if you're out of focus, number one, you can't even tell where you're taking the measurement from until it's in focus. But as you now focus a different meter stick farther away, um, if they were calibrated to be the same height, you'll see that it shifts. And the big problem here, the problem that this is expressing is this instrument is a 1 arc minute error every 3.7 kilometers, and 3.7 kilometers is um, a factor of almost 10 beyond what most theodolites are specified for. So you're trying to use this instrument far beyond the accuracy the manufacturer specified that it was accurate, and then you're trying to insist, oh well, it's still accurate even if I focus on infinity, and that's just not true.
Well, Theodolite has an angular precision, and yours has a 1 minute precision. Now, 1 minute at a distance of 100 meters is a small amount of distance. 1 minute at 10 kilometers is a larger amount of distance. 1 minute at 100 kilometers is a larger distance yet. But you can look through that thing, point the theodolite at anything you want, and the uncertainty is in degrees, not in degrees per meter.
So you are making the common mistake people who don't understand precision measurement equipment make, confusing precision with accuracy.
No, that's not what I'm doing. I'm talking, you call it accuracy, call it precision. A theodolite does not know the distance of the thing that you're looking at. All it knows is the angle at which it's pointing.
So you have a theodolite with fixed focus, and it's infinitely accurate everywhere you point it. That's what you're saying?
No,
Show me that.
yours is one. Sorry.
He'd like to buy one of those if you have it.
Yeah, I'd like to buy one of those with infinite precision and infinite accuracy.
No, I didn't mean that. What I meant in your case, your uncertainty is 1 minute, not 1 minute for 3.7 kilometers or anything else.
Why not?
1 minute.
The compounding error, though.
Yeah.
Wouldn't it increase over distance with that relationship? That's what he's saying.
Yeah, exactly.
The vertical distance uncertainty increases with distance. That's what it means to be a constant 1 minute of uncertainty. If you go twice as far away, the vertical distance uncertainty is twice as great.
You didn't say uncertainty.
You're confusing precision and accuracy. Those are two different things.
I know they're two different things. That's not what I'm doing. I'm just talking about the fact that if you have a precision or an accuracy of 1 arc minute, that translates into an increasingly large vertical distance as the thing that you're looking at is further away, but the theodolite has no idea how far away the thing is. So the amount of accuracy or precision doesn't get worse the further you go away. It's just 1 minute.
So it's as simple as this. If you specify the accuracy of the theodolite in terms of an angular quantity, then when you want to relate that to a linear distance uncertainty, you multiply it by the distance to the object that you're viewing. And so really, I would say more it linearly scales rather than compounding, but you could use that word, but it's a simple multiplication. Uncertainty in length is equal to the distance times the uncertainty of the angular measurement.
I agree with every word you just said.
Well, this goes back to what I was saying earlier. An error in the
if you agree with what he just said, then you agree with what Mike said.
No.
So we're all on the same page.
No, it's the same exact thing, bro.
Eric, were you not just laying that out to lay out Mike's position, and then John was just like, "Alley-oop, bro, that all me." Is that not what just happened, or am I mistaken?
Well, what Mike was saying, I was just
agreeing with what Mike's saying, right?
Yeah, I was agreeing with what Mike says, and also agreeing. John was saying basically the same thing. So I thought I would just give a.
What John is saying is that there should be a linear error, and Mike is saying it's a non-linear error.
Oh,
the difference is
it's the reverse. And what Mike did was show the linear version of the scaling error that John's talking about. So it is valid, and John just agreed to it. And then when I said, "Hey, you guys are in agreement now, so we all agree what this what this is in terms of air," and then he was like, "No, no, no, no."
Yeah, that's
that
right. Because the difference is what I was that Indy who was talking? Who was that talking when I
Yeah.
agreed with? So
You agreed
when
with
I said
Eric.
that, he was saying exactly the same thing. It's the same angular precision all the way out, which means that if you go twice as far away, the vertical precision gets twice as bad too. That's exactly what he just said. That Mike is saying is that the angular precision gets twice as bad when you go further away. That's what it
That's the
means
same
to
shit.
say degrees per meter. It's not degrees per meter. It's just degrees.
He just told you how to multiply it out to linearize it, and you said yes, I agree, and now you're walking it back entirely and acting
I'm
like
not.
it's a different thing. Yeah, you are, and
You're
that
double
kind
speaking, bro.
of
No, I'm not.
buddy, it's on recording. If you continue
Yeah,
this
it
line
is
of behavior,
recorded. Anybody
if
can
you
listen
if
back.
you
It's
if
a
you continue this
constant
line of
angular
if you continue
distance.
this line of behavior, you're going to get banned from here. You're not going to talk over me on my own server either. So please understand that when my voice is speaking, you're not going to talk over me on here.
And if you truly understand this, then you'll understand why on today's celestial theodolite measurements document, I'm multiplying the distance by the angle to find out what the actual deviation is at the peak.
So,
Mike, let me just can I
so
just
wait.
get back?
Hold on, real quick, John. Real quick. Let me ask this question to Mike. Mike, so if you take, like Eric was saying, if you take the distance between your observation and multiply that out with your air thing, it comes out to be 8 inches per mile square between you and what you're observing. No matter how you slice it.
I think it
Like just
comes
about.
out pretty close to that. Yeah,
Yeah.
it varies
Okay,
from
cool.
instrument to instrument.
Nice, dude.
Mike,
Thank you for that. That's a great argument.
I did you get my email, Mike? I sent an email to your Pyrenees rescue thing. I'm sorry if that was the wrong thing to do, but I wanted to ask you where that 4.4944. I think you had said. I think I heard you say that it came out of the manual. Is that right?
So no, that's not correct. And I actually replied to that email.
Oh, I don't think I got it, but I'll look in my
Let
things.
me check here, and I'll tell you when to look for. I'm waiting for email to load. Okay, I replied on March 9th at 2:03 p.m.
Huh. Well, let me look in my. I don't know why my spam filters are usually pretty good, but I'll take a look. At any rate, maybe you can. So be good to get the. Did you send me actually the? I guess Ruhith and Jesse are still waiting for pictures or something. So maybe that's the thing. I guess I don't care too much about that, but I did want to ask about the. Was I asking? No, I wasn't asking about this. What was I asking for? Well, at any rate, getting back to this one for right now. Um, can you tell me how you calculated that Sokia thing? What was the method you used to calculate that Sokia line?
But I'll have to find the spreadsheet and see how I
That's fair.
calculated that.
That's fair. I think I know how you do because I can reproduce exactly those numbers, and I just found it puzzling. Maybe I'll just tell you. I think what you did was you calculated the geometric angle on a globe Earth. That as far those values are, as far as I can tell, exactly what I get for the geometric um, um, elevation angles on a globe Earth.
So I know for a fact that is not how I did it. I'll have to find that spreadsheet and look up how I did it.
When I calculated those things, when I calculated the geometric angles on a globe Earth, I got exactly the numbers that you have there.
Yeah, that's kind of my point, that people are mistaking an instrument error for a globe Earth curvature.
Well, the weird thing about that is the exactness, right? To so many significant figures to get exactly the same thing is almost unbelievable.
So I have a gut feeling about what's causing that, because I noticed the antique theodolites do not have the same error. In fact, they appear to give accurate measurements at infinity. And I think over the years, as people shot more and more mountain peaks, they began complaining to the manufacturer that the theodolite was giving them an incorrect measurement for the curvature of the Earth. And I think after enough pressure from customers, theodolite manufacturers began building the curvature of the Earth into their instruments. But that's just a gut feeling.
Well, you can't do that for the reason that I already said. That theodolite doesn't know the distance to the thing you're looking
Hey,
at.
John,
So
that argument's not going to work anymore because Eric already broke down the equivalence of the linearization of what he did. So if you say that again, like, just know that we all now know that that's not valid, and you also agreed to the derivation and equivalence of it previously before.
No, I didn't.
It was noted that that's what you
Once again,
agreed to, and then
sorry.
you got all upset. So please don't do that again,
No, I
where you
didn't
just
get
start
upset.
repeating the same thing that's already been shown to not be a valid argument.
Well, okay, I understand that you think it's been shown, but it hasn't. The uncertainty is an angle. The angle,
All
that
right,
angle
real
of
quick,
uncertainty
again, Eric,
doesn't
if you
increase
could
with distance.
explain the equivalence between
Explain
what
what?
just happened.
Eric,
Oh,
The
am I
angular uncertainty doesn't
you're good.
increase
Go ahead.
with distance.
I think John knows. I mean, John, it's basically it's the definite. It goes into the definition of related to of a radian. Although you do approximate the linear distance with the arc length at the other end, but it basically an angle times distance is equal to a linear length, and
Right.
so it's the uncertainty in the angle will translate by the scaling factor being the radius or the distance to the uncertainty at the target end.
Exactly.
okay, all right.
And it is
Okay.
Very good then.
One sec. You said exactly. So everything that Eric just said about the equivalence that Mike just put forward for his air tolerance, we're all now in agreement that that's what is being discussed and it's equivalent.
Already know.
How are you saying no? It's literally, he just explained it to you twice.
Well, once again, let me explain.
And you said exactly.
Let me explain it to you. As Eric just said, the uncertainty in angle, whatever it is, and it's fixed, translates into an increasing uncertainty in distance at the target, but it doesn't change the angular uncertainty. The angular uncertainty does not increase with distance at a rate like 4.49 degrees per meter. It's just an angle. It's not an angle per meter of distance. It's just an angle, period.
He just told you how to linearize it, John.
Minute.
He just told you how to linearize it. It's literally equivalent. You're just arguing now against the equivalence of math.
Nope.
You're arguing against yourself now. You already agreed with it twice.
Well, I think what John, okay, I got to remember what he said. John said, it seems like John is saying that there is some angular quantity that in itself is being scaled by the distance.
No, that's what Mike is saying. I'm saying the angular uncertainty is fixed.
Right. If the instrument is not
if the air is at the instrument, but that's like the fallacy of single cause, right?
Well, no, I don't.
I don't
want to be a fallacy. This is just.
I'm just saying is what John's saying is.
Hang on, just
whatever
get back
the
to
angular
the
error
math
is, it's at the
equivalence
instrument.
to that.
Well, Well, hold on. John's saying the angle error is at the instrument, and that should not change no matter how far away the object is. Is that correct?
Exactly.
Okay, that's
Exactly.
fine. But Mike didn't say, hey, it's at the instrument. He's just making the overall statement about there's an error and this is what it is. He didn't say it's at
Well,
the instrument.
error
He
is
didn't say it's at
something
the
else.
lens. He didn't say it's out there in the world. He didn't say it's out there at the object you're looking at. He just say, hey, this is what it is. That's it. He didn't make a
What?
statement about what's causing it.
What?
Dog, he converted the error from radians to a linear distance between the distance and the object. It's
Yeah,
literally
yeah.
equivalent. It's literally the same freaking thing that John's talking about, but how you would describe it linearly for your observation to determine the deviation for that based off of the same thing. Like this has gone into full retard land now.
If the angular error itself increased with
Oh,
distance, then the amount of vertical distance error would increase faster than linear.
It's the same. You're just converting it.
Well,
If I have a
shouldn't
1
you be
degree
able to?
error, sorry, if I have a
I was
1
just gonna
degree
say.
error,
Well, you go ahead. Ken.
But-
I was just gonna see. I think I can resolve it. Shouldn't they can't be equivalent forever because one is squared, right? So at some distance, they're going to start diverging.
so if you have a 1 degree error at 10 feet, then you have about a 57th of a foot vertical error. If you have that same at 100 feet, then you have about a 57th of 100 feet error at that point. But if the angular error itself is getting bigger, then the amount of error with distance increases faster than the distance. And that's not what happens with the theodolite. It's the angle that is the precision. You have an angular precision of 1 arc minute. That means that when you double the distance, you double the vertical error. You don't increase it faster than double. That would mean that the angular error itself is getting bigger with distance, and the theodolite doesn't know.
I can't take it anymore.
Thank you.
Did you mute him? Or did he
gonna
drop?
I thought I got disconnected.
All right. So even what he was
Let
saying
me
is
bring something
incorrect.
up that I think is so. Mike made a full observation, right? He's saying, "Hey, if I make this observation at 10 miles, and then I make observation at 20 miles, and then 40 miles, follows this slope, it's error that increases with distance." Okay,
Right, Dr. Mike?
what John is saying is it's happening at the instrument, and that can't it like the theodolite doesn't know the error shouldn't be increasing with distance. But the problem with that is it's error of single cause. It's a fallacy of single cause, and the 8 inches per mile squared will approximate a slope for a period of time. As like Alan was saying, they're mathematically equivalent for a period of time. They will for a certain distance, but eventually they're going to diverge dramatically, right?
I'm not really sure that's necessarily true, but
Yeah, he said it's
Well,
literally
well,
8
say
inches
like
per
100.
mile square mathematically
Well,
when
you did
you
8 inches per
convert it
mile.
back. Like Eric, is it 8 inches per mile square equivalent or not? Like what's the deal?
Oh,
Well, how can it be equivalent? Because one is per meter, one is squared, right? So eventually the
Because
square
he
is going to
converted
take
it.
over.
well, that's
Oh,
different.
okay.
It's different. One. Okay.
they're related in a
They're
way that
different.
most people don't stop to process, which is why I've revised the way I do the celestial theodolite calculations, because the important thing is the distance times the angle. And I think what people like John and Ruhif are missing is as the peak gets twice as far away, you have to crank the angle down to half what it used to be, and a 4 parts per million error doesn't sound like it a lot, but when you're multiplying that error by 50 kilometers, that adds up.
Right.
So at 50
I
kilometers,
get
100
it. I get
kilometers,
it. I
all
get
these
it. I get it.
odds where they're misusing it, the equivalence works out the same when you with the linearization.
Yep. So in today's document, you'll see that I'm expressing the error in meters instead of degrees, so that it becomes real obvious what impact that tiny little deviation in angle is having in the predicted elevation of the peak. And then the predicted elevation of directly influences what you're going to measure there. So on this
I
chart,
get
it
what you're
gives you,
saying. I completely understand what you're saying. So what you're saying is this, make sure I got this right. That say you measure something at 10 miles and then 20 miles. The object at 20 miles is going to be half the angular size as the 10-mile object. But you're still going to have the same error. But because the other object is half the angular size, the impact is greater on it than the mountain that's closer. Is that correct?
I think that's close enough to correct. It's just they want to say, oh, that matches the globe Earth curve, and they don't seem to understand that's just a linear error term. You're multiplying your inaccuracy of your scale times the distance that scale is measuring over, and for some reason they can't comprehend how those things interact. So I think this new way of presenting the data shows clearly and unambiguously how they interact.
Yeah, I think they're scared to see the coincidence between globe and refraction or error scaling error. It's like he was like, well, this seems like identical to 8 inches per mile squared. You don't say.
Yeah, and if they were identical, you wouldn't have those two rightmost columns be all in red, meaning they don't match. So for Pikes Peak, the globe Earth prediction is it should be 201.8 meters lower, and instead it's 250 meters higher. And you go farther down in the table and you see all kinds of errors like that where the globe Earth prediction doesn't match what the stars, where the stars are saying that peak is occluding them. And then I was kind of blown away by the last one, Mount Rosa, which I only got 2 stars making direct hits on it last night. But you can see one was 3 meters off, the other was 4 meters off. That's the most accurate I've ever been on a celestial theodolite measurement.
That's crazy.
That's pretty wild. And you have
And then
videos of all
you can
this?
see it. Yeah, I do. I got lots of videos, and if somebody can provide me
All right.
someplace I can upload them, I'll be happy to upload them.
We gotta do Telegram, I think.
Yeah, Telegram would be the easiest then. If that ShareNow website didn't work, what was the issue you said you had with it? It needed an email address.
That one, it was asking for an email address to send it to.
Oh, you mean so you there's an option you could fill out to just get a copy paste link that you could share, and then it just emails you a link. What is it called?
Transfer now.
Transfer now.
Right. Just get a link. A link.
Here, we'll see how to do it right now, Dr. Mike.
Yeah, because I didn't want to give out my email for this purpose.
So yeah, instead of send files, click send link.
Well, I didn't mind giving out my email, but it was asking me for a recipient email.
Right. If you click on this tab over here where it says create link, and then just enter your email, so that it'll email you the link in case you forget it. When you upload your thing, it'll just give you a link that you could share, which I'll show you here in a second.
Oh, one important thing. How large are your video files? That's an important thing.
They're, I think the smallest one's around 100 megabytes, and the largest one's about 400 megabytes.
That's not bad.
That should be okay.
Yeah. What's I think their limit's like 2 gigs or something.
What is their limit, Eric?
About to find out.
I think it's about 2 gig or something like that.
Do 2 gigs. No, you can do a 2 gig right off the rip, dog.
Nice.
Shout out to the CIA.
I know, right?
All right, so
Thanks, big brother.
yeah,
big brother.
helping
What a
us
good
out.
big
Yeah,
brother.
yeah. If you could zip those up in a nice file and send me a link, man, that would be so good. And then I could just walk around with this PDF in your videos.
And just be like,
So
what about that?
should I zip them instead of sending them a separate PDF? I mean, separate MP4s.
You could zip them into a single, or you could put them into a single zip and then just send that zip. That'd probably be the quickest
Right.
way.
And if you do need to separate it by peak.
Right, but the thing is, don't the zip file might exceed the. We gotta find out what the limit is. Yeah.
Right.
All right. I got you.
That's what I'm saying. If you do hit the limit, right, then just separate it by peak if you can. Then that'll be easier.
I already have them separated by peak and date and time.
Nice.
Each file name is the date dash the time dash the peak.